Hi, good morning.
Hello, good morning. Good evening, sorry.
Happens. Give me a minute. So clear with all the concepts, whatever we have studied yesterday.
Yeah,
Any doubts in the concepts which we have studied the day before?
no.
So everything is clear, right?
Yeah, yeah.
So probably this session is the last session where we are discussing any topics, and maybe tomorrow we will just conduct a mock interview one more time, and we will be done. Okay.
Okay.
So
Yeah,
let if you have any doubts or if you want to learn any topics, you can ping me so that we can extend the sessions. Okay.
okay.
Yeah, fine. Let me share my screen. Let me know once visible.
Yeah, it is visible now.
Okay, so what we have planned today.
vptr and vtable.
Yes, correct.
And diamond problem as well.
Yes. So if you understand any one of these, you will understand each and everything. Okay. So
Yeah.
I hope at least you are clear with the inheritance part, why the virtual keyword is necessary, right? So today we are going to understand how that virtual keyword is going to make difference. Okay.
Yeah.
Let's say we have a class. I'll call it as a base class, correct? And if you take the size of this class, currently it's 0, right? Sorry, 1, not right. Okay, if we execute that, we know that the size of an empty class is always 1, correct?
Yeah.
Now, okay, if we write some methods, so let's simply let's write method 1 simply, function 1. Okay, for this method we know that there is nothing, no changes will be required, nothing will happen. We will get the same output, that we will get the size as 1. Fine.
Yeah.
Now if we add any data members, size to store an integer is 4, so we'll see the size of this class is 4 now, correct? We have studied this already.
Yeah.
If we add a pointer,
It
if my,
will be 4, 5 again. Or 8.
no, it should be 8, sorry, it should be 4, but I don't know why my system is showing 8. Okay, so
I
let's consider,
think compiler issue, right? Or like compiler is different.
yeah,
So,
just because of the compiler. There are some settings we have to make changes into that, and it will again reflect to those things.
yeah.
Even I'm not able to. Let's try with this. I don't think so it is going to make any changes. Yep. Okay, I just changed the version to uh, but I guess this scenario will get failed. Yep, you can see the size of integer is 4. Again, if we make it pointer, and if I run it, you will see the size is again 4, correct?
Yeah.
Now if we know that, now we know one thing, that size of a pointer is 4 bytes, correct?
Yeah.
Again, we have seen another things as well, like if you add any character, correct, always we will get memory in block of 4 blocks, in chunks of 4 blocks, correct?
Yeah.
Fine. Now currently we are not worried about these things. The moment we will write a keyword called as virtual here, we can see that now the size of this class will become 4. Now the moment it becomes 4, so we can understand that there is a pointer or an hidden pointer called as vptr is there inside this class, correct?
Yes.
The
Yes.
moment we make any function, correct, the moment we make any function inside a class as virtual, automatically a virtual pointer will get created. Okay, so it will look like this, just for example.
Yeah.
Automatically a virtual pointer will get created. Now we are going to understand what exactly is going to happen with the virtual pointer. Okay, you have to pay 100% attention, because if you miss a single thing, it will be very difficult for you to understand the rest of the things. Okay,
Okay.
currently we are not worried about its definition, so I'll just write like this. I'll just write multiple functions. So for three functions, will there be three virtual pointers? The answer is no. Only one pointer is enough to store anything, right? For
Yeah.
example, the moment we have studied about the arrays, correct?
Yeah.
We pass that array to a function, it accepts as a pointer. And using the pointer arithmetic, we can plus it, we can minus it, we can access anything, right?
Yeah.
Execute it, we can again see the size is 4. Okay, so same thing which we are going to understand for another class. I'll write derived one. I will not write any virtual here. Let's say if I do not want to override this method and I want to override this method, correct? It's changed. Member function declared override does not override the base class.
Public base. Yeah.
Missing this, correct?
Yeah.
Now this keyword is optional, so currently we will skip it, but it's okay even though if it's there, so no problem, right? Now
Yeah.
if you check the size of this derived class, what will be the size? It will become 4
Four.
bytes,
4 bytes again because virtual is there.
because there is a virtual function in a base class, and whatever is there in public section, so everything will get inherited, correct? So we
Yeah.
can say one of these functions may get inherited, or all these functions have been inherited in the derived class. That's why size of the derived class is 4 bytes. Clear?
Yeah. Yeah.
Even though there is no virtual function, there is vptr. A vptr exists in this class because
Because this.
indirectly having a virtual function
Yeah. It is.
from
Yeah.
the
It
its
from
parent
the
class,
parent
correct?
class. Yeah.
Now we have to understand how, what exactly is going to happen. Okay,
Yeah.
so let's say we have class. Okay, so this is a base class. It has, let's say, virtual function 1. Currently I'm not worried about the exact syntax, but I'm just worried about the what is the output, what is virtual keyword, right? So
Yeah.
we have these three functions, correct? If we jump here, I guess we have used 3. Okay, so we do not have these two functions. This is not virtual, but we just have a single function, right?
Yeah.
Just draw a line just to indicate that this is overriding. Fine.
Yeah.
Okay, moment we say virtual, so we know that something is going to get added, that is called as vptr, that is virtual pointer, right? The same go here. Automatically a vptr will get added, correct?
Yeah. Yeah.
What is the use of this vptr, what exactly this is going to do, and how the runtime binding is going to happen, we are going to see those things, right? The moment we see any virtual function, okay, if any class contains any virtual function, either 1, 2, or anything, right? So what is the condition? Minimum one virtual function. Okay,
Yeah.
in that scenario a vtable will get created. Okay, so we can write this. Okay, so simply we can say like a vtable will get created. Now this vtable represents to vtable for this class. Clear?
Yeah.
What it will be having?
It will
So
have all the three virtual functions in it, like
correct.
pointers to that.
So it will be having, it's actually a static array.
Yeah.
Just imagine this is an array which looks like this, or we'll just draw it vertically just to understand it in a more better way. Okay, so I'll just
Yeah.
group. Correct. If we talk about this, what exactly it contains, these are the function pointers actually. Okay, so
Yeah.
these are the function pointers. Now what they are going to do, so currently there are three virtual functions. So a stacked or a static array will get created
With three virtual pointers,
with three function pointers.
function pointers.
Correct.
Okay.
Now few things are tricky to understand initially, but you will understand it, no worries. Where are those? Okay, this vtable will point to the vtable means this is the vtable. Okay, so just
Hmm.
make few things clear. I'm drawing in this direction. Clear?
Yeah.
So v pointer points to vtable. Vtable means it's a static array of function pointers, nothing else. Okay, so it
Yeah.
has all the virtual addresses of all the virtual function present in that class. Okay, and now we have three virtual functions. So what exactly they will do, they will just point to a respective functions.
Yeah.
So it will point here, and this will point to this function. Clear till this point?
Yeah.
What what is vtable? A
Uh,
table
which
contains
kind
addresses of all virtual
of
functions.
functions?
Correct?
Yeah.
It get created at the compile time.
Yeah.
Okay, it is nothing but a static array which contains function pointers or addresses of the virtual functions. Okay, we are not studying about the non virtual functions. Okay, so it's specifically with the virtual functions. So let's say if we have one more function, for example. Okay, but it's not virtual.
Yeah.
Correct. So the vtable will not hold any address for this. Clear?
Yeah.
Vtable will hold the address of
Or
virtual
only
function.
the virtual functions only. Yeah. So the normal function will be in the stack, right?
uh, Normal function is these functions.
Like with no this thing.
Yeah. This will be in the data section.
Yeah.
Okay, so this will get created on compile time. The moment we will compile it, the compiler will create a virtual table. Correct, it will
Yeah.
store all the virtual addresses. Exactly same will happen to this thing. Correct. So how many vtables will get created? For each class we will get one vtable.
Yeah.
Correct. So
Yeah.
for each class we will get one vtable. For each class we will get one vptr. Vptr
Yeah.
is virtual pointer. Vtable is virtual table. Okay,
Yeah.
now again it will be having three functions. So let's say, just for simplicity, you can call f1, f2, f3. Again, if this is virtual, it means it has three functions.
Yeah.
Correct.
Yeah.
In if we study about this, where this vtable is going to point to the
Uh,
vtable of that class. Correct.
yeah.
And where this v3 is going to point, this.
Function three. Yeah.
Correct.
Yeah.
Now, what about f1 and f2? Do we have any definition for f1 and f2? The answer is
No. No. So it will point to the base class.
so it
Base
will point.
class base class function pointers.
So it's f2, so it is going to point here
F1 will point to F1.
and point to the f1.
Yeah.
Clear?
Yeah.
These two are pointing here. This is going to point here. Now we are going to write some code here only, just so you will understand everything. No worries. Now let's say if I create base class pointer and I store an address of derived class. Possible? Yes.
Yes.
Right. What will happen if I call like this function 1? We are just going to call all the methods. Okay.
Yeah.
We'll see both the cases. What will happen in case of there is no virtual keyword, and what will happen if there is a
Virtual keyword.
okay, this is optional again, so there is no need. Fine. So
Yeah.
initially we will understand what will happen if there is no virtual functions. Correct.
Yeah.
If there is no virtual functions, these things will not happen.
Yeah.
Correct. So what it will do, it will check what is the what kind of object or what kind of pointer it is it. So let's say it's the base, so it will go to the type of base. Correct. Now this is a class. The moment we are going to call function 1, it is going to search inside the base class.
Yeah.
Correct. If it
Yeah.
does, it's well and good. If it does not able to, I mean it is not able to find it, it is going to give us the error.
Yeah.
Correct. Again, for the second function, it is going to do the same thing. It will go to the base, it will check the data type of the base or what is the type of this base. So we know that this is of this type, so it is going to search in this function, this class. Same for f3, f4. Correct.
Yeah.
Now the moment we add a virtual keyword in front of this, automatically these things will happen. The moment we will compile the code, these things are going to happen.
Yes.
Fine.
Yeah.
At this time, whenever we give call like this, okay, till this point nothing is going to happen. I mean it's the same thing, the same things are going to happen, right?
Yeah.
The moment we are going to call base arrow function 1, correct? So what exactly it is going to do, it is going to give call to the virtual pointer. It is going to say, okay, what is the type of base? Currently it's a base 1, right? So it is going to
Yeah.
give to the virtual pointer, and it is going to ask what is, I mean, do we have any function called as f1?
Yeah.
Correct. So
Yeah.
this will,
It will check.
yes, I have a f1 and it is pointing to this function, right? This
Yeah.
function will, correct.
Yeah.
Same goes to function 2. So do we have a function definition? It is going to say yes, we do have. So it is going to give call to this function. Correct. Now the moment we are going to call this one, automatically it is going to say now we have another vtable, correct, or we have one more vtable where we know, so we have a vtable. Inside that vtable, f3 is pointing to this function. Sorry. Correct. So instead of going by type base, it checks for which kind of object we are holding. So for
Yeah.
it is going to go here. From here, it is saying this f1 is, I have to call this f1. For f2, it is going to give call to this function. From this function, it is going to redirect here. For f3, it is going to say I have f3 and I have to call this thing. Sorry, I have to call this thing.
Yeah.
Clear how exactly these things are happening, how
Yeah.
we are going to get created. Now let's say we have one more class. This is just for understanding. Okay? So let's say we have one more class, and it has derived from, let's say, this.
Again, we are deriving function 3 only, or we're going to derive a
Uh,
different.
so let's say instead of function 3, we have derived function 2. Correct? It's possible.
Yeah.
Now what will happen? Very first, a vtable will get created
Yeah.
for derived 2, right?
Yeah.
vtr, where it is going to point, it is going to point to the vtable, right?
Yes.
Where f1 is going to point, do we have f1 here?
No, it will point to the base class again. Base class
Yes.
definition.
What about f2?
F2, it will point to the derived because definition.
We have, right? And f3,
Yeah.
correct? So now if you remember the yesterday session, whenever we were calling, I mean, we were not overriding this f3, even that time the function was working fine, correct? So sometimes we do not override the function, even though we write it as virtual, we do not override that things, right?
Yeah.
This is how the base class functionalities will get called, and this is how a derived class functionalities will get called, correct? So the
Yeah.
moment we are going to write a vtable will get created. The moment we create a vtable, it is going to say, instead of going by uh, the references, go by the type of the object. So this is called as reference. This is a real object, right? So instead of going by the reference, go by the type of object. So instead of going and checking the vtable of base, always it is going to check by the type of object it is holding. So it will jump to the this vtable, and from the here it is going to give call to those functions. This function will get overridden automatically. So entry for this function will not be there in the vtable. Vtable will be having entries of only virtual functions. If there
Yes.
are virtual functions, there will be no vtable
Yeah.
functions. I mean, vtable will created per class. So for per class, we will be having one vtable and one vptr. Clear?
Yeah. So, but if there is no virtual function, there won't be any empty space also, right? It won't just won't exist the v table, right?
Yeah, it vtable will not exist.
Okay.
We need minimum one virtual functions. Either, I mean, either that class should contain virtual function, or through inheritance it has inherited, correct? So
Yeah.
if currently we do not have any virtual functions here, right? But if
Yeah.
we these functions are inherited automatically, so ideally we have virtual functions, correct?
Yeah.
Understand the concept of virtual, how virtual table works, how virtual pointer works?
Yeah.
Is it clear?
Yeah.
Now if this is clear, you will understand why
Yeah.
the size of this class is 4, correct? The reason is, the moment we are creating any function as virtual, automatically we can see the size has increased to 4, because a hidden pointer is there which exists in the that class, and pointer size of any pointer is 4 bytes.
Yeah.
Clear?
Yeah. So, but it will only show 4 bytes as the size of class, right?
Yes.
For
Yeah.
all.
Yes. Even though you add 10 virtual functions, the size will be 4 only.
Yeah.
Okay. What will happen if we add one more pointer? It will
8.
change 8. 4 plus 4. Correct?
Yeah.
So there, looking at this, it looks like, I mean, it's only 4 bytes, but 4 bytes will come for this. Clear?
Yeah.
Now let's try one more thing that is called as diamond problem. So I'll write a class. Let's say write something. So a famous problem called as something called as diamond problem, right?
Yeah.
Understand it diagrammatically first, and then we will go to the code. Okay. So let's say we have the same hierarchy we are going to draw here. So this is class A. It has a data member A, and it has a function called as E. Correct? Yeah, simply I'll write like this. Fine.
Yeah.
I hope this is easy to understand. So the parenthesis indicates it's a function. underscore indicates it's a data member. So we have 4 classes, that too in hierarchy. Here we can see it's a B class, it's B, class C, C, D, D, correct? Now, how the hierarchy has, what is the hierarchy? So from this we got inherited this one. From this we have inherited this one. Again, this class is going to inherit this. This class is going to inherit this class. Okay. Now what's the problem? So whenever we say inheritance, right? We know that whatever is there in the parent class, everything will get inherited in the child class, correct?
Yes.
So we can say we can have a data member called as A here and a method called as A here.
Yeah.
We can say, right, which is coming from this, correct? To understand it, we can say like this. Okay. If we do the same things, we have a data member like this, and we have a member function like this, correct? So these things are coming from the base class, or simply I'll just change the font color, which will be easier for us to identify. I'll write in red. So whatever is red, so we will consider that is coming from A. Okay, till this point. Whatever is coming, so this is green. So this is blue. And I have to change it to red. Fine. So whatever is indicated in red, that is coming from class A. If anything is in green, that is coming from B. If anything is in blue, that is from C class. Now, if we see here, knowingly, unknowingly, we have B here, we have C here, and we have 2 copies of A. Correct?
Yeah.
One is from A, one is coming from, even though both are same, correct? Either you go like this or you go like this, both are exactly same, correct? I mean, we are pointing to the same variable, but these look different. This is coming from C, this is of own. Again, we have a function called as B, we have a function called as C, and again 2 copies of function A. Correct? Sorry, it should be, I'll say A, B, I'll say A, like this. Right. So this is class D. It is coming from ACA, then AB, AB and A. Correct. So whenever we give call to the function A, so it gets confused. Or the compiler will get confused. Now, which A function I have to call? Whether which is coming from the class B or whether which is coming from the class C. Correct. So it gets confused. Whenever we refer to this data member, it gets confused. I mean, I have to call the data member which is coming from the B class or from the C class, correct? So it creates some ambiguity and the compiler gets confused, correct? This
Yeah.
problem is called as diamond problem, correct?
Yeah. Yeah.
Solution to this problem is keyword called as virtual.
Yeah.
Correct? The moment we write virtual, what exactly it does? It is going to do again vtable everything, right? And now it is going to hold the address of, I mean, for each class, it is going to, I mean, it will came to know that I have to keep only 1 copy of everything coming from the parent. So the moment it sees, okay, there are 2 copies, and I mean, there are 2 copies of the method. Let's say this is the method, right? So there are two copies which are coming from class A. So it is not going to store two copies. It is going to say, I will store only one copy, because both are going to refer to the same thing. The moment you write virtual, it does it automatically. Correct? So it says there is no need to maintain two copies. I'll just keep only one copy, and the diamond problem will get resolved.
Yeah.
Correct? So how we can resolve that issue? Just
Oh,
by virtual keyword here.
yeah.
Correct? The virtual keyword is in the parent class of the last class. It's not in here, right? We have to write here. So
Yeah.
automatically it says whatever I am getting from my parent, I'll just keep only one copy of it. And if the parent is going to give me the same copy twice, I'm going to keep it only one copy. Correct?
Yeah.
It's called as diamond problem.
Yeah.
And the solution to the diamond problem is virtual inheritance. So this problem exists in C++ only. So from Java onwards, they have removed the support for multiple inheritance, and they have said that you cannot achieve multiple inheritance using classes. So you have to make use of interfaces to make use of. If you want to achieve multiple inheritance, then you can make use of interfaces or those things. Okay,
Yeah.
if this is clear, then we are going to learn the last concept. Mm, let's say we have a class base. We are going to learn the basic things. Okay, so currently we are worried about the constructor and destructor only. Correct? So I'll just write this class setup. Correct? I'll write a derived class. It is, we are going to inherit it publicly from class base. We are going to write the same things again. Simple, the class structure.
Yeah.
This class, constructor, destructor, nothing else. And we just printed a message so that we'll came to know that what exactly getting called, at what time it is getting called, right?
Yeah.
We are going to create multiple objects. So let's say if you create like this, now you just have to guess the output. What will happen? Which constructor will get called?
Base class constructor.
Only base class constructor. After this, base class destructor. Correct?
Yeah.
It is going
Yeah.
to it is going to destruct it.
Yeah.
Right? Let's say if we create like this, even this in this scenario, you will see the same thing. The base class constructor, base class destructor. Correct?
Yeah.
There are no such things, no twist till now. But if we do something fancy, like if we create like this derived d, what will happen? Why it is giving me the problem? Let's try. Oops. Is the class name? No.
What error it is showing?
Oops. Okay. The constructor was private.
Oh, okay.
You can see, we can see now the base class constructor will get called first, then
And
the class constructor will get called, and exactly reverse case, first derived class destructor will get called, and then base class destructor will get called. Is this
yeah.
sequence how? I hope this is clear, right? I mean,
Yeah, destructors are called in reverse order. So the first object that is created, latest object that is created, that will be deleted first.
so what we have to remember is the base class constructor will get called first, correct? And then derived class, and the destructor calling sequence is exactly opposite of constructor calling sequence. Clear?
Yeah.
Now, if we do like that, so derived d was working fine. And if we call like this new derived Correct. This is one more way. Now we'll okay, so you can see a base class constructor got called, and then derived class constructor got called. The destructor is not called yet, so let's delete D. Everything is fine, right? Base
Yeah.
class constructor, derived class destructor, base class destructor. Even those cases works fine, correct? I mean, we did not get any issue till this point. Now, if we change our few things, usually which we do, always we create base class pointer, correct?
Yeah.
Whenever we do anything, we create references of base class only, and we create objects of derived class. So after that, we are going to delete it. If we run it, okay, now you can see base class constructor got called, derived class constructor got called, then directly it called base class destructor. So it forgot to destroy the derived class object, correct?
Yeah. Yeah.
Right?
Yeah.
Now, let's say, just for example, okay, star p, and we are going to create p equals to new int. Let's say I'm going to add a random value, and here I'm going to say delete p, correct? You can say derived class or memory deleted. Now we know that the derived class destructor is not getting called, correct? So
Yeah.
you know we have created a dynamically allocated memory in the derived class, so it's our duty to delete it, correct?
Yeah.
See, that memory is not getting deleted, correct?
Yeah.
So now it's a problem because we occurred a problem called as memory leak.
Yes.
Now
Because the memories are not getting
we have,
cleaned up, which we
yeah,
have used.
we have created the memory, but we have not destroyed it.
Yeah.
Ideally, we have wrote the delete statement, but it is not getting called at any time, correct?
Yeah.
Now, why this is happening? The reason is again simple. The moment we are trying to delete it, it is going to check what is the data type or what is the type of base. So it is of this class, correct? So it is
Yeah.
going to this thing only. So
Yeah.
that's why we create destructor as virtual,
Yeah.
correct? What is the meaning of it? The moment it will find this as virtual, so instead of calling this destructor, it will call this destructor,
Yeah.
correct?
And
That
it doesn't matter even if we are deleting via the base class pointer, as long there's no memory leakage now with
correct. Now if you see, the base class constructor got called, then derived class constructor get called, and then automatically derived class destructor get called. We have deleted the memory and base class destructor will get called, correct?
Yeah.
In case of virtual destructors, both the destructors will get called. Clear?
Yeah.
Now, what is the scenario? In this scenario, do we need base class destructor as virtual? Answer is no. Both are pointing to the base class, right?
Yeah.
So we are not worried about the derived class now. In this scenario, no, correct? Because we know this, the type of D is derived, so it is going to give call to the derived class destructor for sure, correct?
Yeah.
But in this scenario, correct, where we have reference of a base class and object of derived class, in this scenario we need the base class destructor as virtual.
Yeah.
Is it clear?
Yeah.
So is it the case that we need the derived base class destructor as virtual in all the cases? The answer is no, correct? Let's say if we do not have any dynamically allocated memory here, so is there any point, I mean, let's say if I do not call this destructor, is it going to is it going to create any impact? The answer is no.
No.
Correct. But
Yeah.
if our is a derived class, we want to destroy the object of derived class completely. In such scenarios, ideally we should write base class destructor as virtual.
Yeah.
Here,
Yeah.
anything else about anything else? Which is not clear or from the day one till today's point.
No.
Any topic which we need to revise or which we have not covered. Anything.
Regarding STLs, how much do they ask regarding STLs?
Some companies do ask about the STLs. Okay, specifically they will ask you about the vectors. What
Vector
are
map
what
and
maps they can ask you, right? If you are good at collections in Java, or I guess same things are there in Python as well, right?
yeah.
So they are the same. Few companies they do avoid using STLs. Okay, so uh, I don't know why, but I have seen these things. Few companies they said if you know STLs, it's a good thing. Few
Yeah.
companies say we do not use STLs. So let's say if they give you some problem statement and if you are using STLs, then it's a negative impression. So
Yeah.
when if anyone is, let's say if I'm going to interview you, right, and if I
Yeah.
ask questions to you, and you know that using STLs it is going to be very easy, then you should ask before using the STLs directly. You should ask, can I make use of STLs? If he says yes, then you can go for it.
Oh, yeah. There's also like I've like learned about templates. What templates are there? Exception handling is try catch basic. I
Correct.
think.
Yes.
Template. I think smart pointers is something I'm confused
Smart
about. Is
pointers is a feature of basically what is smart pointer. See, just a simple thing. Okay, so you will understand it very easily. Now we have created this memory, correct?
yeah.
So it's our duty to delete it,
Yeah.
correct? So what are the smart pointers? Basically, these are the wrapper classes over the pointers. Okay, I'll just say like this. So let's say I have constructor. So this is the value which I'm going to store inside a constructor, right? So what I'll do, pointer equals to new int number. In the destructor, what I'll do, delete ptr. This is the simplest way to understand smart pointers. Ptr, delete ptr. Where say ptr is going to be, right? You can write some methods as well. Get value, any methods. Okay. Star ptr, it is going to return the value, right?
Yeah.
Just imagine if I create an object of it, correct? It's pointer ideally. If I create an object of this, okay, so I'm going to give a name as pen. So is my memory allocated dynamically? Yes.
Yes.
Do I have to delete this memory? No.
No. No.
How? If we write like this,
Uh, because the destructor is getting called, right?
automatically, yeah, you can see. No, if I run the code, we know that automatically the memory is going to get allocated and automatically it is going to get deleted. Correct. So what are
Yeah.
smart pointers? These are nothing but the wrappers. Wrappers over that you can use templates here, correct?
Yeah.
Forgot the syntax, but if I'm not wrong, it's something like this, correct? or what should we type T? I forgot the syntax for this. Let me check the syntax for it. Let in C++. Type name actually. Type name T. You can write like this now. Again, this will become T. Instead of this, we will use T. So every time you have to use like this. Correct? So now T becomes the value. So whenever you want to create, let's say I want to do it with the integer type. Now everything will get converted into integer. I hope there are no issues. Yep. Correct? So allocating memory, deleting memory. Let's say if I want to do it for a character. It's just an example, okay? So let's we are doing it for the float.
We don't use the keyword unique ptr here
There
before smart
are
pointer.
inside smart pointers we have if I'm not wrong 4 types of pointers are there, right?
Yeah.
Unique pointer, shared pointer, and rest two where I forgot rest two. Okay, so there are 4 types of pointer. Now the funda is kind of similar. The moment we say unique pointer, it means you can assign only one value to it.
Yeah.
So there are 4 pointers. Out of those, one we do not use. I mean that is kind of deprecated thing. Correct. The shared pointers, you can have multiple references over it. So inside smart pointers, even if you read theory, this is the internal implementation of any pointer, any smart pointer. Correct. The basic funda for all the smart pointers is that there is no need to call delete. The memory will get destroyed automatically. And how this is implemented? This is implemented using a class, a simple class.
Yeah.
Okay. So whenever you study about the smart pointers, just read the theory, what exactly that pointer is going to do. So I forgot the names of all 4. Let me do it again. The types, yes. So weak pointer we do not use it, right? So we have unique pointer, we have shared pointer. The moment we say unique pointer, so we can point it to only one value, something, right? And
Yeah.
the moment shared pointer, so it is we can have multiple references over that. So that's the only difference.
Yeah.
Clear?
Yeah.
Anything else?
No, not right now.
So this is how the internal implementation of any pointers works. Even in Java, the same things are written. So in Java, we do not have any keyword called as delete. So memory management happens automatically.
Yeah.
Right. So this is how it works. So we have created a pointer, correct? But the end user doesn't know about it. Ideally, we have created a pointer, right? So we are dealing with the pointers only. Let's say if I want to take read the value, so what is the option? I can say get value. You can see we will get value here.
It should be 10, right?
Yeah, we will get 10 here. You can see value 10, we will get 10 here, right? You can get address, you can point it to null. So there are multiple things. So
Yeah.
you can write getter setters. I mean multiple functionalities can be exposed. So it's up to the developer what functionality he is going to develop. And this is how the internal implementation looks like. I have tried to keep the things as minimum as possible. So a constructor, a destructor. So even though we are not deleting the memory management takes place automatically.
Yeah.
Clear?
Yeah.
Anything else?
No.
So tomorrow we will be having a session, but you have to prepare like an interview, which is going to be a proper interview. So we'll be connecting for 1 hour. You have to prepare each and everything, whatever we have learned from the day one. Clear?
Yeah. Yeah.
And if you have any doubts before interview, you can clear the doubts with me. Okay?
Yeah.
I mean, it's possible that, I mean, while studying, you may face some issues, and you may, I mean, have some doubts. So before starting the interview, I'll ask you if you have any doubts. If you have any doubts, then we will resolve those doubts. And if you do not have those doubts, then I'll consider that you don't have any doubts, and we'll start with the a kind of mock interview where you have to share your screen. You have to explain each and everything in detail.
Yeah.
Clear?
Yeah.
So starting from the data types till the virtual table, vtable, vpointers, then how the virtual destructor works, when we need it. Correct?
Yeah.
Ready for that?
Yeah.
Perfect. If you need anything, ask it. I don't have any issues. Okay.
Yeah.
Maybe tomorrow's session will be the last session. Fine.
Yeah. Yeah.
Yeah. Then we will connect tomorrow. Okay.
Yeah. Yeah.
Bye. Good night. Oh, sorry. I
Bye.
have.
Yeah. Good night. Good. It.
It's
It's
night
good
here.
day here. Yeah. Yeah. Good night.
Bye.
Bye.